today we are going to see how Maple can help us work with functions, computing limits, and study continuity of a function. So the first thing we have to do is just to open the tutorial, which we have already prepared. Now once we have Maple, okay, have our tutorial, and now what are we going to see? We are first see how to define functions and to do graphical representation, to plot functions, how to compute limits of a function at a point, and how to study continuity. So let's start with how to define a function in Maple. We have different ways, but the most important thing is that you have to know this syntax. So it's the name of the function, colon equal. This is the same symbol we use to define variables. So then it comes the variable itself minus greater than, this I will call it an arrow, and then the function itself, x squared. So in this case, remember to make Ctrl-J, Ctrl-K, and then press F5 to change from Math2D to Math1D. Once we have a function defined, we can evaluate it at a point. So f of 2 would be 2 squared, so it's 4. F of 3, it's 3 squared, it's 9, and you can keep on changing the number, and then you get the value of the function at this point. An important thing is that you usually forget how to define a function, but you have here in the expression palette, you have this button here which you can press. Always remember to press it in 1D so you get it in red, and then again you put the name. We for instance can make a name J X, and then for instance just say sine of X. Okay, this should be an arrow. I don't know why it's not seen clearly. This should be X arrow X square. Okay, so this is how we define functions of one variable. We could also define functions of two variables, but now in this course we are not going to use them. So it's the same notation, but now between parentheses we put the two variables, or 3, 4, 5 variables, and then the expression will depend on these different variables. For instance, in this case, if I compute f of 2 and 3, so it's sine of 2 times 3, sine of 6. Okay, so usually we use functions which are quite simple, but sometimes we also need to define functions which are defined piecewise, by pieces. Okay, this is the way how you do it, is piecewise, meaning a function is defined in different parts, and then you put the first condition, comma the first function, the second condition, comma the second function. Okay, sorry. You can also do these piecewise functions with two different parts. You can always do it. Look at my cursor, which is in 2D. You can press this button here, and now you change minus x, tab button, x less than 0, x greater than 0. Once you do this, okay, this is really simple to do. If you have two different parts, you just go to Math2D. You will not be able to see it in the window, but it's Math2D convert to Math1D, and then you get the same result. Okay, so if a function is defined in two pieces, it's really easy. You can do this and then convert. The problem is, what about if a function has 3 pieces? The only way you can do this is just by copying this and understanding that how the function piecewise works. So you have a condition here, the first function, a second condition, second function, and then you can add third condition and another function, and you can keep on going. So you can do, if x is greater than 2, then it would be a sine of x. Okay, so if you have to define a function with two pieces, you can come here to the expression palette, but otherwise you should use the piecewise command. Okay, so you now know how to introduce, to define functions and to use the piecewise command. Now let's see how to plot. We'll start with this exercise, and I will show you different ways to make plots, so you can choose between or which one is more interesting for you in any case. So Let's further this exercise. Define the following function using the palette. So if you don't remember, just use this button here, J tab button. Now the variable is s, and then we have s squared plus square root. If you don't remember the function, you just put square root, abs, the absolute value, and then the logarithm and the s. Now you see that you get j of s. Let me check something. Yeah, it's not working a lot. This is the zoom, so you can change from one another, and in my case you cannot see directly the arrow, but here you can see if I make it bigger, you see that this is an arrow. So you have the function here. Now evaluate the previous function at x equal 10, and then both directly and using the command subs. So directly means I just put j of 10 and I get the result. If I want it in decimal numbers, I just have to put j of 10.0, or there's another way of doing it. So let's add some more command lines. So another way is to just write j of s and right click with the context sensitive menus, evaluate at a point, evaluate at a point, and type the point, which is going to be 10. Okay, if you do this, you get the eval command, so you are not using the command that we have been told. So we copy this, and now we look for the help of the subs command. So we execute the line, we open the help, we go to the examples, and then we copy one of them. So the command is used placing subs, then the point where you want to substitute, and then the function. So in this case, what we should have done is substitute at the point 10, and then here we have to put, well, if we want to put it using an s, it's like this. So in order to change it to decimal, remember that you can always do this. It's not working now, but you can also use the right click, the context sensitive menus, and say approximate to 10 or 20 decimals. This command, the command it has been used, is the eval command, and then you can change how many places you want. Remember that this does not give you the number of decimals, but the number of total numbers. So if we want 5 decimals, since we have 3 numbers before the comma, we should put 8. Okay, so now we know how to define the function, we know how to evaluate the function, and now let's see how to plot. The first thing, or the first way to do the plot, let me introduce more lines. Remember that I always like to have more than one line, at least one. Now, first thing, using the context sensitive menus, you can see that you have the plot option, and you can make a 2D plot. This uses the SmartPlot command, which is the fastest way to do it, but you cannot control anything. -10, 10, the axis, the color, and everything. If I change here the color to blue, and I again do the SmartPlot command, you'll see that you lose what you have changed. Okay, you can change the axis to boxed. Then once you execute it again, some of the changes are lost. Okay, so this is a nice way to do it because it's really fast, but if you want to control what you are plotting, this is not the best way. The second way is to use the PlotBuilder. This is a nice way to do it. So we just write j of s, and instead of using a 2D plot, we are going to use the PlotBuilder. Okay, and with this we are going to be able to change these options that we have been told. So 2D PlotBuilder. This will open a new interface, and here you see that we select a 2D plot, but you could do other things. The x-axis they told us that they should go from -5 to 5, and then we have to change different options. So we press the button options, and let's see what we can change. The vertical axis, here we can place a Y. Here they told us that the vertical range should be from 0 to 5. They also tell us, let me see how it's okay. The title should be representation or 2D representation. Then line style, they said that it's going to be a solid, but we could also use dash or dash dot or dot. Let's change it to dot for now. And this is the thickness, so it can be thin or thick. Let's use thick. Okay. And also we have to change the color, so we would use either here or change the color here. So we would come here and, I don't know, choose magenta, for instance, which is the one that we have been taught. Once you have all the options, you have changed everything you need, you can preview it or directly plot it. So which is the advantage of this plot builder than SmartPlot? That we can control all the options. So in particular, if we just change this to 1D, which is the standard way to put it, this is the function, so this should be J of S. We have the range from S equal to -5 to 5. Okay. Now, the vertical axis from 0 to 5 has been placed here, okay, using the view option, but it can also be placed here from 0 to 5. Okay. Line style dot, we can change this and place solid or dash, any of the options we had. So if you go here, line, you can change everything, but if you do it here, once you replace this, you lose it. So just you can look at this and say dot. So I come here and I put it. You can also put numbers. 1, 2. Let me check it again because it's not working now. Well, let me check this. Let me put default because otherwise. So line style while. I don't know why it's not working now. Okay, so you should be able to change it, but since I'm using this one, it's not working, so I'm going to delete the plot and do it again. Okay, now you'll see 1, 2, 3, 4. Okay, or just put the name. Thickness, I'm going to put solid so that you see it correctly. It's a number between 1 and the number you want. Okay, and it's the thickness of the line. So once you know how to change the thickness, you don't need to do it again. Color, you have fax here, but you can also put red or blue. You can change the color now, F or J of S. Label directions and labels, we don't need that. Okay, it's the same thing. So if you use the plot builder, after you get your plot, you also could control the things, and then obviously you can change the things. So it's easier once you have it here to change it and to recover the same plot. Okay, this is the second way, and the last way to do it is just by using the plot command. And the arguments, the minimum things that we have to put is plot the function and the interval. Okay, and after that, as you have seen, you can introduce any of the options: line style, thickness, color, title, and everything. But the fastest thing that I would use to make a plot would be this one. Okay, and then if I need to control the X range, I will put it, and if I need also to control the Y range, I will change it here. Okay, so this is usually how we do plots, but you have the different options, and if you don't know how to do plots, of course you can always use the plot builder. Okay, so I suggest that you use always the plot builder before then using a SmartPlot. So now that you know how to plot functions, let's see a tutorial which is really helpful to study functions. So we'll follow this afterwards, but first we are going to, there's a mistake, we are going to introduce a function. Remember that you have the button j of x, and now we introduce x to the power 4 minus 17 times x to the power 3 minus 51 times x to the power 2 plus 1377 times x minus 2430. Okay, so before entering the tutorial, because we don't want to write the function again, we will just copy the expression. Okay, so j of x, we copy the expression, and once we have it, we are going to go to Tools, Tutors, Calculus, Single Variable, Curve Analysis. So we make another line and we proceed. Tools, which in Spanish is herramientas, Tutors, tutorials, tutoriales, Calculus, single variable, cálculo de una variable, Curve Analysis, análisis de curva. Okay, so we just press this and it will pop up a window. Here we just paste the function, and they are telling that we have to make the study from minus 10 to 10. So we say display. So this is the function from which we want to make a study. Maximum. If we press this button and press calculate, you can see that Maple is telling us that we have a maximum at minus 10 and another one at 5.3. So this is the absolute maximum inside the interval, and this is the relative maximum. We can also change to minima and calculate, so you would get that a minima is located at 5 minus 5.15, and then the other minima is located at 10. And then you can also see increasing, the function is increasing between minus 5.15 up to 5.30. You can see also this by looking at the line color, which is this red line color. Decreasing, there are two intervals, which is the function where the color of the line is blue, this interval and this interval. Then the concavity, you can always see this blue and magenta. This blue is where the function is concave up, concave down, and again here you have concave up. Inflection points, you have two inflection points. One here is where the color changes, and the other one here, really small. Okay, and 0 is the place where the function crosses the x-axis, so it's minus 9, 2 and 9. Now this information is really useful, but if you want to get it on your worksheet, you have to compute it, and then the only way you can do it is by copying, Ctrl C, and now once you have closed it, you place the cursor and you paste it. If you want to do it again, in order not to write the function again, here you can introduce the two basic arguments, which are the function and the interval. So you would do that, and then if instead of the maxima you are asked for the minima, you just compute them, copy, close, and paste them. Okay. Sorry. The only thing that makes this tutorial not really useful is because it provides information with really few decimal places. So if you just need to know the maxima or minima with 1 or 2 decimal places, you can use this tutorial. But if you need to know this point with more decimal places, you should use another thing. Okay, so we will see this in the following tutorials, but for now you have this really interesting tutorial which allows you to study the behavior of a function. So now that we know how to define a function, how to plot it, and even how to use the curve analysis tutorial, let's see how to compute limits of a function at a given point. So let's see first the idea. The limit of a function at a certain point, for instance, the limit of this function at the point x equal 2, tells us the behavior of the function around this point. Okay, so for instance, if we look at this function, we have that if we get closer to 2 from the left or from the right, the values of the function tend to 3. Here you have the table where we tend to 2 by the left, we take values approaching 2 by the right, and then the images, this one's which in red, this one's in blue, both of them tend to number 3. So in this case we will say that the limit of the function when approaching 2, number 2, this 2 on the x-axis, is 3 because the images approach to 3. If we consider this other example here, as we take points approaching 1 from the left, the images tend to 1. But if we take points approaching from the right, the images tend to 2. In this case, we cannot say that the images tend to a single number, so the limit would not exist. However, we can define the left limit and the right limit, the left limit, or the limit from the left or the limit from the right, the limit from the left being 1, which is this succession, and the limit from the right being 2. Okay? So in this case we would say that the limit does not exist, but the limits, the directional limits would be, the two-sided limits would be 1 and 2. So let's see how to compute these limits, not by making tables but by using directly Maple. So let's directly do it. We are going to learn how to do it with the palettes and also using the functions. We make some lines because we'll need them. We change F5, F5. So okay, so now to define this function, since you can do it if you know how to use the piecewise command, but let's do it with the expression palette. Sorry. If we want to use the expression palette, it's better that we have the cursor in Math2D mode. So we have -1, x less than 1, and then 1, and now we have x greater or equal. So if you don't know how to do it, you can go to handwriting, try to write it as best as you can, and then see if you get. Okay, so in this case would be this symbol. Otherwise, you can also use, sorry. Okay, let me see. You can always use greater and then an equal, and then you see that the symbol changes. Okay. Now we have the function. We need it in 1D mode, so we convert it using 2D Math Convert 1D, or as you have seen, if I just paste something in 2D when I have the cursor in 1D, it becomes in 1D. So now we need to say that this function is going to be function f, so I press the function button, the variable is x in this case, and the expression is this piecewise. If you want to check if you are doing it correctly, you just have to put f of x and then you get the expression. Okay, so limits. Let's start with 2D mode. So now I undo what I've done, and I have the limit button. So I press it, X, tab button. The limit is, they are asking it the limit at 0.1 of f of x. And Maple say it's undefined. Okay. Now let's see what happens with the two-sided limits. If I want to do the limit from the left, we just have to come here to the 1 and press a minus, and we get a -1. And if I want to do the limits from the right, I just put a plus here and I get -1. In this case, the two-sided limits, the limits from the left and from the right, they do not coincide. This means that the limit does not exist, and this is why Maple says it's undefined. Okay. Now let's see how to do it in Math 1D. We copy these three expressions and now just convert them one by one. Then we will look at them. So if we want to compute the limit, we just have to say limit of the function, comma, which point. If it's from the left, instead of a minus at the side of the point, we just say comma left or comma right. Okay. Again, we get the same results, so if the lateral limits they do not coincide, the limit is undefined. So this is how easily you can compute limits in Maple, just by using the palette or by using the limit command. Finally, let's see a tutorial which allows to compute the limits step by step. This is going to be useful in some cases only. So let's open it. Tools, Tutors, Calculus, Single Variables, Limit Methods. We open the tutorial and we will start with this function, x squared minus 1 divided by x minus 1 at the point 1. So we start, and let's see how we are going to do this limit step by step. We can press get hint. It's going to give you some advice. So Maple is asking, is there any way of simplifying this rational function? And you should look at this numerator, which is x squared minus 1. This means that it is x plus 1 times x minus 1 and can be simplified. So if we do one step, next step, here Maple says that the factor rule has been applied. So Maple has factorized this and then simplified. And then this is just separating the limits, computing first the limit of a constant function and the limit of x. Okay. Now again, if you want to have this on your tutorial, Control C and paste it below. Otherwise, yes, you see that you just get the final result. We can do this again. We can copy this instead of going. We open this again. And now let's see why this is not really useful to study in this course. So limit, start, and let's see here in class you are going to be using a technique which is not the one you are given. Notice that this is an indeterminate form. So this is a 0 divided by 0. And if I do next step, Maple says that he has applied the L'Hopital rule, and you are not going to be using this rule in this class. So this is not really useful for studying, but at least Maple tells you that it's an indetermination, so you need to use the techniques that you are going to be told in class instead of applying the L'Hopital rule. So again, you can copy this if you want and paste it. Okay. So as I have said, anytime you get an indetermination, if it uses the L'Hopital rule, is not what you're going to do in class, but at least you know that you have this tutorial, because in some other subjects maybe you can use the L'Hopital rule. So now we know how to define functions, we know how to compute limits, and now let's see how we can use this to study continuity. The limit of a function at a point mainly is used to study the continuity of a function and to define derivatives. So the concept of limit is really important. So now, when we say that a function is continuous at a point, a function is continuous at a point if the limit of the function at the point A coincides with the value of the function at this specific point. Here, even though you have two expressions, there are three numbers involved. There are the value of the function at the point and the two lateral limits, the two-sided limits, the limit from the left and the limit from the right. So whenever studying continuity, you have to compute three different things: the two limits, the two lateral limits, and then the value of the function. Now, depending on these three values, you can have different types or kinds of discontinuity. If the limit exists but it does not coincide with the value of a function, this means that we have a hole in the function. We will say that the discontinuity is removable. We will have a jump discontinuity if we have that the limits of the function, the lateral limits, have a value, for instance 1 and 2, 1 and 3, but they are not the same. Okay? So this will be a jump, and then the essential discontinuity will be when the lateral limits do not exist. The most frequent case is because they go up to infinity or not, but there are some different cases. So To study discontinuity, you have to compute 3 values and then see in which case we are. So now, study the continuity of the following function at the point 0. Which is the kind of discontinuity? So let's start. Since we have a function which is a piecewise function but with only 2 different parts, we can just use this in 2D directly. So here we have the square root of the absolute value here of x if x is less than 0, and then the sine of x plus 2 if x is greater or equal than 0. Now, since we finally are going to be working in 1D, we just copy it and convert it. Okay, so convert to 1D or paste it in 1D. And now we have to define this as a function, so we use, even we write directly this, okay, or if you don't remember how to do it, just press this button, X, and then the Y is replaced by piecewise. Again, check that everything is correct after you've done it, type f of x and you get this. Now, before starting the continuity, let's plot the function. Okay, so let's start with the easiest way. So since we are starting the function around -1, let's do from -2 to 2. I'm sorry, let me check that everything is correct. Okay, so let's open a little bit. I have done some mistake. It's not x less than, sorry, it's x less than 0. Now x less than 0. Now it's okay. This is the function, so around 0 you can just put -1, -1, and if you change the axis to boxed, then you get a strange plot. This is because this function is not going to be continuous, so in order to Maple to plot it correctly, you have to add an option which is discont equal to true. What does this do? This option tells Maple that this function may be discontinuous. So before plotting, Maple looks at the discontinuities, finds them, and it doesn't plot the straight line. Okay, so the difference between having this and having this, it's really clear that this is well plotted and the other one it's not. So here, if you want to have it with the same axis forever, it's axis box. So if I remove the plot, the axes are going to be okay. So now, of course, we see that this discontinuity is a jump discontinuity, but let's compute the limit. So let's start. I'm going to do it in 1D. If you want to do it in 2D, you can. So the limit, we are going to study the limit at 0. Obviously it's undefined because the lateral limits are not going to be the same. So copy this. Limit from the left, limit from the right. They both exist, but they have a different number, so this is a jump. And don't forget to evaluate the function at the point. So we have these 3 values. 2 of them coincide, but the other one is not. Since the limit does not exist, but they are numbers, we have a jump discontinuity. Okay? So in any example, you should compute these 3 things, limit from the left, right, and the image, and see which coincidence you have, and just look at this table. Okay? So now that you know everything you need to know, you have these 3 exercises here. Well, first 2 of them. Okay? Commands discont, and then you have these trickier functions where you have to compute and classify the discontinuities, and then you have these other 3 exercises that you can check and see if you know how to do it. Remember that you have all the commands that you need to use, so you just have to look at the help and use them. Okay, so this would be all for today.